Good afternoon, everyone. In our last lecture, we started discussing about grid computing. Basically, we are discussing about different type of computing. So, first we have discussed about the traditional client and server architecture. Then I told you about peer-to-peer architecture, in which there is no dependency between one node with another node. Then we started grid computing. I told you some of the definition given by IBM, some of the definition given by Sun Microsystem, as well as PCOgopedia.com. So they have defined the grid computing in a different way. Then the concept of grid actually start from electric power grid, like we are getting electricity in our socket, right? But simply you have to switch on your fan and or you switch on your light, right? But without knowing that how these electricities are transmitted, where it is generated, we don't care about it, right? In the similar fashion, in comparison to the electric grid, we have grid computing paradigm, which is consisting of a set of resources like processor, we have storage, we have network. So this shows the difference between electrical grid, where we consider only electricity, but here we are considering the components related to computing. Then we have discussed when to use grid computing paradigm, when you need massive power, where your single computer system is not enough to execute a particular work. In those cases, we can go for grid computing paradigm. Then we have discussed what is the need of grid computing, because enhancing the capability of a single computer system or a group of system is practically not possible to achieve a particular goal. So for that, we need actually the resources from all individuals, right? Or you can say voluntarily, people can join a particular network or they can leave a particular network, right? So that is the main purpose of going for grid computing. Okay. Then in last, we discussed about who uses grid computing. I told you there is a project, there is a platform that is called as BOINC, that is called as Berkeley Open Infrastructure for Network Computing. It consists of set of projects. So you can participate in these projects and you can share your computer resources, right? So these things we have already discussed in the previous class. And in the last part of last lecture, we started discussing about different types of grid. So basically, there are 5 different type of grid. First one is called as computational grid. Second one is called as data grid. Third one is called as collaboration grid. Fourth one is your network grid. Fifth one is called as your utility grid. Okay. So let us discuss one by one. Basically, computational grid and data grid is much more popular in comparison to other grid. We discussed already about the compute intensive and data intensive. So if I ask you what is the difference, then you can tell that compute intensive case, we are dealing with the large computation power, whereas data intensive case, we deal with a large volume of data. In the similar context, if you see here, computational grids provide secure access to a huge pool of shared processing power. Like we have a swimming pool, right? In real life, we use swimming pool. Swimming pool contains a plenty of water, right? Suppose you take a cup of water from a swimming pool, it is not going to affect that particular swimming pool's water. In the similar fashion, there is a huge pool of shared processing power is there, okay, and from which you are providing resources to different users. And especially computational grid is used for high throughput application. I already mentioned you about high performance and high throughput application. CPU can be used for high performance application, even if GPU can also use. But the vision of cloud computing is to go for high throughput applications in which you can use GPUs. The GPU is more powerful than CPU. And computation intensive computing. Right? That is the main goal behind the computational grid. How faster we can execute a particular work. That is on your computational grid, irrespective of the power. Whether you require a 1 gigahertz processor or you require a 5 gigahertz processor or any size of processor, okay, or any number of cores. Like if I ask you how many cores you have in your computer system, then somebody can say 2 cores, somebody can say 4 cores, somebody can say 8 cores, right? With respect to different system, you have different number of cores. So you can expand to any number of cores when you go for computational grade. But these cores are not belongs to a single system rather than the part of a set of system. Now coming to the data grid, so unlike a huge pool of shared processing power, here we are dealing with a large volume of data. Like Facebook case, one of the real life example we are seeing in day-to-day life, where it is having a very huge amount of data. Imagine how many users are there, and imagine how many posts people are doing in Facebook, how many photos they are uploading, how many video, audio files they are uploading. So if you look into that, we are dealing with a large volume of data. That's why data grid provides an infrastructure to support data storage, data discovery, data handling, data publication, and data manipulation. Not only storing the data is important, but also retrieving the data whenever it is required, that is important. Right? Like you have stored some files in your computer system, but whenever it is required, if you can retrieve those files for your usage, then you can say it is fruitful. So actually we have a large volume of data, and these are not only stored in a single database. We have different databases. Like we have seen in distributed application, we have number of databases, right? A number of databases, and these databases are present in different location of the world. They are not located into the same location. Moreover, the size of these databases are also different. That's why we call this a heterogeneous database and a file system. That is called your data grid. So primarily, actually, we call there are two different type of grid only. One is computational grid and data grid. Later point of time, based upon the usage of grid computing, people call collaboration grid or network grid or utility grid. Now come to the collaboration grid. In collaboration grid, you need to join one or more organizations, or you can say two or more organizations, not one, two or more organizations. If two or more organizations decided to share a large volume of data or to process a large volume of computational power, then they can build a computational grid. So definitely in future also, when there is a resource scarcity happen, like many researchers suggested that future of cloud computing rely on integration or collaboration between multiple cloud service providers. So one day will come, there is definitely a scarcity of resources, or we cannot expand the resources due to our environmental constraint, due to cost constraints, due to business constraint. At that time, one cloud service provider has to collaborate with another cloud service provider in order to deliver the service. Like I told you one class about related to mobile network. You visited a particular place, there your mobile providers has no signal, but your mobile provider, okay, or your internet provider collaborated with other internet provider. So you are getting the tower of that provider. So it is really an example of our collaboration. So in a particular company also there are different branches are there, like multinational companies. when they are going for software development process, when they are solving a particular complex problem, they are relying on each other. The different branches are working together to develop that particular product or develop that particular software. So in that case, also they can use collaboration. And one of the advantages you can see, whatever underlying technology you are using, or whatever proprietary technologies you are using in each and every branches of your multinational company, you need not disclose that technologies. While you are making collaboration, collaboration does not mean that you will reveal everything, but the minimal uh, things you have to disclose. But with respect to the technology, you did not disclose such technology. Still, you can make a collaboration and then complete the work. One of the popular example is our computer-aided design project, which we call as CAD project. There you need not disclose the proprietary technology. Still, you can collaborate with different components of a particular project. You can collaborate with different enterprises as well. That's why collaboration grid is required when multiple organizations solves a single common problem. Right? Now coming to the next grid, that is called as network grid. So it provides fault tolerant and high performance communication services. Fault tolerant says that even if there is a fault exists in your network, like in your network, if you have 5 nodes and one node is collapsed or one node is failed, so it is not going to impact on your network performance. So you have to build a system which should be fault tolerant. Obviously, it is no single point failure. But even if there is a failure happen in your system, not necessarily it is a single point failure. But any failure happen in your network, right? You have to see it is not impacting the performance of your network. It is also high performance communication services. Communication services really depends upon the bandwidth, right? When you connect one component with another component, one node with another node, then the communication becomes faster if the bandwidth is more, right? So in the network grid, our objective is to make the faster communication services. So here each grid node works as a data router between two communication points, and it provides data caching and other facilities to speed up the communication between such points. The multiple communication points are there, multiple communication nodes are there, right? So each node has to ensure this data routing between multiple data communication points. And we have to see that how we can minimize the communication. Because whenever a customer requests a particular request, not necessarily the request has to reach to the main server. Rather than you can create a replicated server and you can place this replica of the server in various places, right? So whenever a user initiates, we will see which server is near to that particular user, and we are going to provide the services to that particular user. In that way, you can process the customer request, you can say in a faster manner, right? The last type of grid is called as utility grid. Already we discussed what is utility. I told you there are 4 different type of utility. First utility is our water. Second is our electricity. Third is our telephone. Fourth is our gas connection. And the fifth utility we are saying our computing is the fifth utility of the system. So utility grid is the ultimate form of the grid in which not only data, if we are talking about data, you can say data grid. If we are talking about computation, you will say computational grid. If we talk about network, you will say network grid. Or if you need integration of something, you will say collaboration grid. So utility grid is not only focusing on this, but it also focuses on software and resources which are shared among multiple peoples. It is not only the data and computation cycles are shared, but also other things are also shared in the utility. Just like we are paying some amount and we are getting the service. We are going to a particular restaurant, we are paying some amount, we are taking the food. That is also a utility, right? So utility is not restricted to a particular component, but it varies with respect to a lot of components. The main services provided through utility grids are software and specific equipment. One of the example you can see here, the application can be run on one machine and all the users can send their data to be processed to that machine and receive the result back. Especially if you look into client server architecture. In client server architecture, client initiates the request, right? And it is reaching to the server and server actually process it and get back the result. And there is no one client. There are set of clients are there. Each client is doing the same work. They are making a request to the server, and server has to complete that work and return the result to the client. That is also like an utility. The time you have used for the used to execute a particular work, right? That time for that particular period of time only you have to pay for your service. You did not pay for the infrastructure owned by that particular server or the cost of that particular server, maintenance of the particular server, management of that particular server. So that is the main goal behind the utility grid. Now here you can see a set of user component. Like here, especially there are three important components of grid computing. One is user. User means you may be a user, I may be a user, your friend may be a user. Anybody wants to get resource or share resource. You want some resource or you want to share your resource voluntarily, then you can be a part of our grid. Second is groups. Like if you talk about our institution, in our institutions we have several computer systems. So if you look into these computer systems, I can say these computer systems, these computer systems are nothing but a group of systems. Like if you talk about our computer lab, we have 50 computer systems. Similarly, other departments are also having computer lab. In that computer lab, we have some more computer systems. So together, we have a set of computer systems. If we decide that our organization or our institute has to collaborate with some grid project, okay, so what we will do, we have to manage a particular group. You have to manage a particular group and can participate in the grid project, right? That is also not only as an individual only you can participate into grid computing project, but as a group also you can part of that project also. Similarly, various sites also can be participate in the project where you can collect the resources or you can contribute to the grid. So similarly, you can see a lot of things they talk about here, like users. It may be the large and dynamic populations, right? Like if you go for a cloud simulator called as Cloud Analyst, in that tool you will see there is a user base. In user base means we have a set of users and each and every individual user has a set of requests, right? So we call that as a large and dynamic populations. Anybody can participate, anybody can leave, anybody can join into the network. Similarly, we have different accounts at different sites. One of the site I already mentioned, that is called as search for extraterrestrial intelligence, SCTI at home. Right? This is one site. There is another site you can say NFS at home, okay, or NFS nfs.com, right? There is another site like that. There are number of sites that are present in BOINC platform, right? So you can participate into any number of sites. If you have installed BOINC, then you can see any number of sites you can participate and share your resources. But whatever data you have in your device, that should not be revealed, right? So privacy, confidential data, personal data should be maintained properly. Then You have heterogeneous privilege. Heterogeneous privilege says today you may be a user. Tomorrow you have, let's say, a large amount of resources. Let's say as an admin, you can access to all the computer systems available in your organizations, or you can share the resources that are available in your organizations. So you can act like an user or you can act like a provider also. That's why your role is different. Sometimes when you request a particular resource, you may be a user. When you are providing the resources, you are a provider. So you may switch over from one role to another role. And also it is a single sign-on. With the same credential, you should do multiple activity. For multiple activity, there should not be different sign-on required in the grid project. Today you have participated in one project, tomorrow you have to go to switch to another project. So that credential should be used to log in into other sites as well. Coming to groups, in group means special, you can say membership. Those people who are member of the group, they can share the resources. At a later point of time, they can ask the resources as well. So that is nothing but a group of people participating rather than the individual people participating in the grid network. Similarly, when you talk about sites, we have heterogeneous resources because you cannot gather a large amount of resources, but a set of resources are participating together to provide the things, right? Okay. Similarly, we have various set of policies. Different sites are having different policies that you have to follow, right? Like how much resources you can share, that may be one of the policy, or whether you can decide that how much time you can make active your computer system to participate in the grid project, that can be one of the policies. So there are different policies are there, and overall you can see the time zone and different organizations, what those who are participating in the grid project, that is different. One person can participate from US, another participant can participate from India, another maybe at Singapore, and maybe any place. But together we want to form a grid which is nothing but providing a large amount of resources. Now, this is all about the one of the trade, that is grid computing. Let us proceed to the next computing paradigm, that is called cluster computing. So all of them, as I mentioned earlier, they are part of our parallel distributed computer system. Whether it is a cluster or a grid or a cloud, these all are a type of parallel distributed computer system. If you compare the grid with cloud, or grid with cluster, or cluster with cloud, so you will see the resources are different. Like cluster case, we focus on homogeneous entities, but grid case, we consider about heterogeneous entities. And if you go for cloud case, it may be heterogeneous or it may be homogeneous in nature. So what I want to mean that like if I ask you to gather 100 computer systems of same configuration, or I can say 100 computer systems are having same architecture, then you may collect it because the number is very small. But when I increase this particular number from 100 to 10,000, 20,000, it is not possible for any individual or any organizations to collect 20,000 or 30,000 computer systems of same architecture, same configuration, same characteristics, same behavior. So in that case, when you are unable to collect it, but you can collect different resources, they are having different architecture, different operating system, different characteristics, we go for grid computing. But cluster is a very simple form of computing where we gather the systems are having similar architecture. So here you can see cluster consists of collection of interconnected stand-alone computer. Stand-alone means they are not dependent on other. Like in a particular computer lab, you have 30 systems. So you can say these 30 systems are stand-alone computers. And in order to make a cluster, what you have to do, you have to connect these 30 systems. That's why we say we have to connect the standalone computer so that they can work together. They can work together as a single integrated computing resources. If somebody asks you how many systems you have, as a provider, you will say there is exactly one system. But behind that system, you have a number of standalone systems. That's why when we go for a cluster, we want to group a set of standalone computers to integrate them and so that as a single resources. That's why I told you one word that is called as a single system image. It says that group of computer systems are connected together, right, to provide a single computing resources. They are integrated together. That's why they are providing a single, they act like a single resources. So when you merge the computer systems, standalone computer, they are not only the PCs, they may be workstations, they may be symmetric multiprocessor, they may be different form, not necessarily they are personal computers or laptop or desktop. You can combine anything which is having some processing power and storage power. For example, symmetric multiprocessors, or you can say workstations, and you can say also you can also connect to multiple operating systems. Okay, these are also these operating systems, high performance interconnects, middleware, parallel programming environments like MPI, that is called as message passing interface, or OpenMP. These all are parallel programming tools or programming frameworks that you have to use in the cluster. So these are some of the major components of our cluster computing systems. Okay, so another important term here you can note down, that is called as middleware. So middleware is generally used to provide you an abstraction. You know, in object-oriented programming, we have studied something called as abstraction, data abstractions. So abstraction is nothing but hiding some internal details. So middleware is used in the cluster to hide the complexity of the environment. You have to not to show what is there in the environment. That's why I told you they are integrated together to show as a single resource. Okay, so that is the main goal behind the cluster computing. But the nodes are homogeneous in nature. But grid case, the nodes are heterogeneous in nature. But you can create multiple clusters. For example, you found 30 systems are having same configuration. So you have made a cluster. You find another 50 computer systems are having same configuration. You can make another cluster. So one cluster you have made with a 30 computer system. Another cluster you have made say 50 computer system. Another cluster you can make 40 computer systems. So individually they are called as homogeneous systems because they are having same configuration, same architecture. But when I make them together, then we call that as a heterogeneous cluster because the number of systems, number of processors, number of architectures may be different. That's why there may be 3 different clusters. If I want to connect these 3 clusters, then overall I can call them as heterogeneous cluster. Now you can see clusters are usually deployed to improve the speed. Like one computer system is not sufficient. In place of one computer system, if you have 30 computer systems, so your power is increased by 30x. Right? One computer system is x power, then 30 computer system will give you 30x power. So definitely you have improved the speed, the reliability over that provided by a single computer. You cannot increase the single computer speed by 30x. A single computer speed can be increased by either 2x or 3x. Right? You have 2 TB, tomorrow you have decided to go for 4 TB for storage. That is possible. But you cannot increase 4 TB to 40 TB. Similarly, today you have 2 cores, you have decided to go for another 2 cores. 4 core is possible. But you cannot increase it to 40 core. That's why in that case, where single computer systems are not providing you enough power, we are using cluster. So here you can see, while typically being much more cost effective than a single computer, then of comparable speed or reliability. Obviously, if I compare one computer system with a cluster, the cluster is high performance because it has providing massive power rather than the computer system. Not only that, it is cost effective, right? You did not enhance the power of each and every computer system. Rather than you are combining multiple computer systems to provide a massive power. So in a typical cluster, you can see you have network. You need a faster network. There is a interconnection that is called as MIDINet. You can search in Google. So MIDINet is used to connect different computer systems in the cluster. Basically, we need a faster communication, closer connection than a typical network. Like local area network you are using in a particular building or a hostel to transfer some data. Cluster case also we need a faster interconnection network that is called as MIDINet. You have to also see that latency. Latency is nothing but delay. So you have to see that delay should be as minimum as possible. That's why we call here low latency communication protocol. Nowadays protocols are developed as a lightweight protocol. If you go for heavyweight, then a lot of features you have, but it is becomes more slower, leads to low latency. In order to avoid that, what we are doing, we have to go for high. You have to look into the latency, and you have to go for lightweight protocol. Lightweight protocol has may not provide you a lot of functionalities, right? But they can invoke different functionalities and provide you low latency. Similarly, they are loosely coupled than symmetric multiprocessor. Symmetric multiprocessor case, one system is having multiple processor. In comparison to that, if you go for cluster, like if a system is having multiprocessor, if a processor is failed, it may impact other processors. But when you go for cluster, if a node is failed, it is not going to impact other computer systems. That's why we call that as a loosely coupled system. Like you can take an example of your class. In your class, you have a class representative. So whenever a faculty member or whenever your institute wants to communicate some message to all individual students, then if I call the class representatives and inform something related to a particular message, then your class representative can circulate that message to each and every student. It also same as a cluster computing paradigm. It is a non-technical example, but if you relate with a technical example, it is same as your cluster computing example, right? So we entire class is visualized as a single class representative. Right? Whole class is represented as a single class representative. So once I inform something, then that is going to connect that message is circulated to each and every individual. Right? That request is going to each and every individual through your class representative. And if any communications the students want to, they need to inform to the class representative. Then class representative has to forward that message to the concerned authority. This is also an example of the cluster computing. Like class representative, in cluster case, we have a cluster manager. The cluster manager is a node which controls all other nodes that are present in the cluster. Right? Just like a node, a particular node is selected as a cluster manager. So whenever you want to execute something in the cluster, you have to send the task to the cluster manager. So it is the responsibility of the cluster manager to circulate this task or divide this task and circulate among all individual nodes and get back the results. Now, like we have seen different types of grid, like computational grid, data grid, collaboration grid, network grid, and utility grid. Similarly, clusters are also divided into three different types. One is called as high availability or failover cluster. Second one is called as load balancing cluster. Third one is called as parallel distributed processing cluster. High availability. What do you mean by high availability? High availability means if something is available for 24 into 7 in a particular week, then you will say it is high available, right? But do you ensure that if a system is active for 24 into 7, it is providing you better performance? That is a question mark. Somebody is there for 24 into 7, right, to execute a particular work, but he is not doing. Then it is not providing you high performance. So high availability is not ensuring you high performance. But availability is a major constraint. If a system is available, then only you can utilize it, right? And even if there is a failure, if primary is failed, then secondary has to take the role of primary. And as soon as possible, you have to recover from that particular failure. So you have to make available another node, right? Because if the secondary, which is now considered as a primary, if it is also failed, then another node has to consider that one. That is called as your failover cluster. Okay. So our objective is to make the nodes available and make them work, make them execute the work whenever they are available in the system, right? So that we can achieve not only high availability but also high performance. The second cluster is called as load balancing cluster. Like there are number of requests are reaching to, let's say, one centralized unit. Let's say this is our centralized unit. Like if you say internet case also, many users are browsing the website, same website. So number of these requests are reaching to centralized unit. Now what the centralized unit will do, it is connected to a number of servers. Let's say it is connected to three different servers. Let's say they are S1, S2, S3. So the centralized unit, or you can say it is also a manager, it has to ensure that each and every server is getting equal number of requests. If there is an uneven number of requests reaching to different server, so it may happen that a server may crash. Okay, server may fail. So this centralized unit is doing the work of load balancing. It balances the load among three different servers. It ensures that none of the server is overloaded and none of the server is underloaded. That's why I told you, one computer system you are not using, but it is switch on for 24 into 7. So you can say that system is available, but what about performance? Performance is it. Not only availability is important, but also performance is also important. But load balancing cluster says that at any case, one should not be overloaded, one should not be underloaded. Similarly, one should not be under provisioned, another should not be over provisioned. So it ensures that principles, you can say, or that type of rules. Next one is called as parallel and distributed processing clusters. Okay, so you know distributed means different places we have number of different clusters. So we have to coordinate among different clusters to execute a particular work. Like that, different classifications are given in different research articles, different books related to different type of cluster. Now, if you look into component, like grid case also, we have seen three different component. One is user, another is group, another is size. So here you can see the basic building blocks of clusters are broken down into three parts. One is your cluster node. Second one is called as cluster network. Third one is called as network characterization. Okay. So here you can see how these things are connected to each other. So these are called as your node. There may be multiple cluster also. Assume that in each and every cluster, if you have n node, you can consider this one as a cluster. You can consider this one as a cluster. Like that, there may be a number of clusters also, right? So we need some centralized unit or a manager to coordinate among these different clusters. Otherwise, how will come to know whether a particular server, a particular cluster is overloaded or underloaded? So you need to know, right, what is the load of each and every individual cluster. So for that we have a switch, right? We have a switch. Although switch is not an intelligent device to take care of this one. The switch is connecting to different type of different clusters, or you can say different nodes of the clusters, right? So you have to take an intelligent decision to know that which part of the work is going to execute in which cluster, in fact which node, right? Which task you are assigning to node 1, which task you are assigning to node 2, which task you are assigning to node n, how to consolidate the results generated by these nodes. For this you need some centralized unit to take care of that particular thing, right? So these are the cluster nodes. Whole network is called as cluster network. And network categorizations, you can see that whether it is a small task or it is a medium task or it is a large task, based upon that you can make network categorization. Now some of the, you can say, key operational benefit of clustering. Why we go for clustering? Because clustering we can get a massive power which we cannot get by the help of a single computer system. So the first advantages of going for clustering is system availability. The system availability offers inherent high system availability due to the redundancy of hardware. You have studied something called as a redundancy array independent disk, called as RAID in operating system. There are different level of RAIDs there, and you have seen different schemes used in different level of RAID. So RAID is especially the redundancy of hardware. Okay, similarly, you can say redundancy of the operating system, redundancy of the applications. Why we want to make it redundant? Redundant means duplication, or you can say replica. The reason of doing the replica is that to increase the system availability. Okay, our objective is to increase the system availability. That's why we are making multiple copies of the same hardware or operating system, or you can say application. Second one is called as hardware fault tolerance. Yes, I talked about RAID. So redundancy of most system component, like this case we are using RAID. So not only redundancy of software is required or hardware is required, you require both. Okay, in order to make it more available, right? Similarly, we have operating systems and application reliability, which runs multiple copies of operating system and application through this redundancy. I'm creating multiple copies of operating system. If anything is failed, one particular copy is failed, then another copy is running. So you will not face any difficulty. Similarly, we are talking about the scalability. Scalability is nothing but you can add a server to increase the computational power of a network, or you can reduce a server also whenever there is no requirement of that particular server, or when you not require the computational power. So adding servers to the cluster, or by adding more cluster to the network, as the need arises or CPU to SNP. Whenever there is a requirement, you can increase it. Whenever you don't want such a requirement, you can reduce it. Scalability means you can go in scale up or you can go for scale down. Not necessarily scale up. Right? Today you have started a company. Tomorrow you have seen there are number of requests coming to your site. You increase it. You make it scale up. At a point of time, you have seen, no, again the number of users are reducing. You can make scale down. So scalability is providing you a flexibility to increase or decrease the resources. The last one is called as high performance. High performance means running cluster enabled program. Right? High performance you can achieve if you do multiple works at the same time. But throughput says that how much work you have completed for a particular period of time. So that is called as high throughput. High performance also you can use CPU and GPU. High throughput also you can use CPU and GPU. Okay, but cloud case we focus on high throughput application. But when you go for cluster grade, they rely on high performance applications. And the last part that we are going to discuss in the trends of computing before we start cloud computing, that is called as utility computing. In utility grid, I mentioned about water, electricity, gas, and telephony. The main objective of utility computing is to provide such type of services. So utility computing is purely a concept which cloud computing practically implements. The word utility which you are using in day-to-day life, if you go for computational world, computing world, the same thing we want to implement which is there in our real life with the computing world. That's why it says that this concept is purely implemented in cloud computing. Maybe business purpose also, right? Cloud is meant for business purpose, right? But grid is meant for scientific engineering purpose. But the overall objective is to make an utility. So based upon the uses, people are going to use it. If there is no use, then people are not going interested in that particular service. So utility computing is a service provisioning model. If you want to get a particular service, you have to make a request. Like client server architecture also I told you, client make a request, server replies to that particular request. Similarly, here also, a user make a request to the provider replies with that resources, whether resource is available or not, whether it is success or failure. Process our service provider has to return a reply to the user, right? So it is a service provisioning model in which a service provider makes computing resources and infrastructure management, which is available to the customer as need. So who is maintaining the infrastructure? Infrastructure is maintained by your provider. Who is adding computing resources? Addition of the computing resources is done by your provider. Why a provider is doing this one? To provide services to the user. And user can get these services as and when needed. So as user is requesting the services and getting the services from the provider, so users are charged for that. Charged for the specific usage, or they are charged in a flat rate. Like I'll say you, like internet provider case also. Suppose we have subscribed to a particular provider for internet service at our home. So they will say you can use unlimited internet service, right? The flat rate is you have to pay, let's say, 1000 INR. It is a flat rate. It is already mentioned. You can use as much as possible, but you have to pay 1000 rupees per month, right? Or they have another scheme. They will say based upon your usage, you have to pay. For example, 1 rupee per 1 MB. Let's say a simple example. So if you have used 1000 MB, you have to pay 1000 rupees. But if it is less, then you have to pay less. 500 MB means 500 rupees. So you have to decide whether to charge them in a specific usage or you have to go for a flat rate. But most of the time we rely on specific usage. Utility computing means we focus on the specific usage rather than the flat rate. So utility computing model has the advantages of a low or no initial cost to acquire computer resources instead of computational resources are essentially rented. So if you want to go for a startup company, initially you have shortage of amount, you have shortage of your budget, you don't have sufficient amount to purchase infrastructure, either computational infrastructure and other type of infrastructure also. So when you have low initial cost, in such cases, you can go for utility computing. When subscribe to the cloud, and you can pay per month basis or per week basis or as per the plan decided by the user and the customer. And you can acquire the computer resources, maybe network, maybe bandwidth, maybe storage, maybe anything that you need, you can acquire, but no need to purchase any infrastructure. The way we are purchasing a laptop, desktop, that such requirement is not there when you go for utility. So the word utility is used to make an analogy to other services such as electric power, which is a utility that seeks to meet fluctuating customer demand. Every month you are getting different bill in electricity. There is no fixed bill, right? That's why I told you most of the utility are charging with a specific usage. They are not charging in a flat rate. But some providers are also providing in a flat rate. Irrespective of usage, you can get. If you want a long-term service, then obviously you will go for a flat rate. But if you go for a short-term service, you will go for specific usage. So just like electric power, where every day our requirement is changed, every day our consumption is changed, every month our bill is also different, right? And charge for the resources is based on usage rather than flat rate basis. But if you are not using the electricity, suppose you are away from your home for 3 4 months, then you can say base charge. Let it be 100 rupees or 200 rupees. That is constant for each and every month. But if you are using the services, your amount is varies with respect to different months, right? So this approach is called as our pay for use basis, or sometimes we call it pay for usage basis. So based upon our use, we have to pay. Right? If our usage is more, we have to pay more. If the usage is less, our use is less. Right? Now, here you can see it has given the example of utility computing. It has usually envisioned some form of virtualization. Virtualization means utilizing the physical resources in the form of virtual machines. We have physical machines, but if we create virtual machines on top of the physical machines to utilize the resources that are available in the physical machine, for which we have used a technology that is called as a virtualization technique. I'll tell you more about the virtualization technique in later classes. Virtualization is very popular prior to the cloud computing also, but it is really used in the case of cloud computing to improve the utilization of the resources. So the amount of storage or computing power available is considerably larger than of a single time saving computer. The virtualization means if there is a physical machine which earlier dedicated to a particular user, now the same physical machine is dedicated to multiple users. Like if you say our computer system, you are computer system. So check the utilization. Your utilization is low, right? But if the same computer system used by let's say multiple people, your friend and another friend, then definitely utilization of that computer system is going to increase. That's why this computational power, storage, they are considerably more usage when there are number of users are increasing, right? So that you can make in the case of utility, right? So the needy user can use, and whenever they required also they can use just like a utility. That's why utility computing is a very powerful, you can say, computing paradigm. In fact, cloud is also a utility computing. Now you can see where you can, what are the models in the utility computing. First one is called as pay for use pricing business model. One of the example I'll tell you here. For example, I'll tell you, you have to pay, let's say $1 for CPU per hour. So if you want a resource in cloud, the cloud service provider has to pay. Cloud service provider has to provide you a resource for which you have to pay $1 per CPU per hour. So if you have used for 10 hours, then you have to pay $10. But if you have used multiple CPUs, right? This is per hour. Per hour, per one CPU, the rate is $1. For an example, if you are using for 10 hours, then you have to pay $10. If you use 10 hours, two CPUs, how much you have to pay? Can anybody tell? You are using for 10 hours, but two CPUs simultaneously.
20, sir.
Yes, it is 20. So per CPU you have to pay $10. So total you have to pay $20. That's why I request you, you have to go to Amazon Web Service. You can note down this thing, AWS, that is called as Amazon Web Service. Create a free account in Amazon Web Service. Creating account in Amazon Web Service requires your basic details, like the way you are creating a Facebook account, the way you are creating a Google account, or any website you are creating an account. Like that, you can create one account in Amazon Web Service. Once you sign up, okay, or sign in into, first you sign up, then you go for sign in. Once you sign in the in Amazon Web Service, they will ask you the payment information. In payment information, you can provide your credit card and debit card information. Once you provide credit card, debit card information, some nominal charges will be deducted from your account, and that is also refundable. For example, the way you are creating a account in PhonePe or Paytm or Google Pay or any API, right? Sorry, any UPI. So in order to validate your account, they are deducting a minimal amount, and after deducting that minimal amount, they are also refunding that particular amount, right? So once you have provided your payment information and payment information is verified, you can use 750 hours of free service, 750 hours of free cloud service. You can also use 5 GB of storage in Amazon, in your Amazon account for 1 year. Like we store the data in Google Drive, you are uploading the photo into your Google Photos, you are storing a particular location in Google Map. Similarly, here also you can store 5 GB of data into Amazon server. And this data you can share with your friend whenever required. You can share with anyone in the world, right? Similarly, you can create a resource and you can use that resource for 750 hours. But how many hours are there in a particular month? 750 of hours per month you will get. Can anybody calculate how many hours are there in a particular month?
Sir, near to 750 only.
It will come as 720. Do it 24 into 7 into, if I take 30, how much it is coming? Can anybody calculate? 24 into 7 into
720,
30?
sir.
720, right? So why they are giving 750 hours? The reason of they are giving 750 hours, they know that you cannot use 24 into 7 into 30 days, right? But you can create multiple instances. Rather than focusing on a single instance, you will focus on more than one instance. Parallelly, you are running more than one instance. Suppose I am parallel, like you mentioned here. If I am using 10 hours, two CPUs, if the rate is $1 per CPU hour, then $20 is deducted. So if I consider the hours, it is nothing but 20 hours. So 10 hours for two CPU, right? Two CPUs are running simultaneously for 10 hours. So totally it is 20 hours. So this 20 hours is deducted from your 750 hours, right? So what we are building here, the business model we consider here, it's called as pay for usage, pay for use pricing business model. Based upon your usage, you have to pay. But note that once you exceed the 750 hours, then they will deduct from your mentioned account. So you have to ensure that you are taking good accountability, right, of these 750 hours, whether you have exceeded or within the quota that you have to look in. Because once you exceed, they will directly deduct and you will get a bill from Amazon that this much amount is deducted from your account. And that bill is generated per month basis, right? Similarly, these different resources where our providers are providing, each provider has a data center. Amazon has a data center, Google has data center. Each and every provider has data center. So the technique they are using to provide these resources is called as virtualization. So we call that as a data center virtualization and provisioning of the resources. The resources are provided from the data center, right? And as and when required, you can make a request and you can get this request from the data center. So obviously, the resource utilization problem is solved, right? Like I mentioned you in one class, like if somebody is using 7 hours computer system per day, so seven, if there are 6 working days are there, 7 into 6 is 42 hours. But in a particular week, we have 168 hours. So total utilization we are getting is 25%, right? But if the same computer system can be used by other, let's say another user is using another 42 hours. So this calculation you can make like this: 84 divided by 168. Now you can say the utilization is 0.5 or 50%. Obviously, the resource utilization problem is solved. So whenever you have multiple users, definitely the resource utilization is improved. Because if you see prior to cloud computing, the utilization are very, very low. Like utilization of a personal computer is only 5 to 10%. Like prior to COVID, if you see where we have offline classes, in such classes, nobody uses the computer system. It's because it is an online class you are attending through your computer systems or your institute computer systems. That means you are utilizing your computer system. But offline classes, we are not using our system. That means our system is idle. We are not using our systems, right? It is completely idle. It is of no use, right? That's why the resource utilization is sharply reduced. Not only case of the personal computer, but also if you look into the server case also, the utilization is increased to only 30 to 35%, not beyond that one, right? So that is also problems related to the servers, right? So our objective is that by using this virtualization technique, how we can increase the utilization of personal computers, workstations, PCs, anything, okay? Not only server, all the things, all the computational devices, how we can improve the utilization. That is our overall objective. And utility computing is also a outsourcing company. Like, outsourcing means just like suppose in your home you have a maid, right? In your mess you have a maid. In your institute you have sweepers, right? So these people are assigned a particular job. Based upon their work, we are paying some amount to them. Okay, we need not bother. They are not the permanent employees. They are not going to stay in your campus for long period of time, right? Temporarily, they are assigned a particular work. They have to work. It's because we don't have these many people to work. We have called these people and given some task, so they have to complete that. It is same as our electricity. We are getting electricity. We are not bothered about who is giving electricity, in what manner electricity is coming. We simply pay and we use the electricity. Right? That's why everything is outsourced. Right? Like we are using cloud, but these resources are not a part of our computer system. It may not be provided from our country. It may be from outside of the country also. So these things are outsourced. Similarly, we have web service delivery. So everything is nowadays we call that a web services, right? Similarly, nowadays we call that as a microservices. Microservices are a lightweight services. The advantages of microservices is that if a service is down, it is not going to affect other services, microservices. So this is a web service delivery. Similarly, this entire process, what I am telling, this process is completely automated. The process is not manual. At any point of time, you can create an account and you can use the services that are provided uh, by your cloud service provider. Now you can see here, here is an example of your utility computing. Here there is a user, right? Let it be a scientist or a user or any person, right? He is making a particular request, okay, for a web service. We call that as a on-demand web service. So he initiates a particular request. He initiates a request that I need these are the requirements for this particular web service. He has to mention the requirement, like whether you need a one CPU or you need a two CPU or you need a four CPU or you need 2 GB of space or 8 GB of space or 16 GB of space, that you need to specify. Once you specify, then only your cloud service provider has to provide it. Once you make this a request, the request is going to the virtual machine repository. So I told you virtual machines are a part of, there may be multiple virtual machines. They are taking the resources from the same physical machine. Okay. This virtual machine is taking resources of physical machine one. This VM also taking from physical machine one. This particular virtual machine is also taking from physical machine one. So first we will go for the virtual machine repository. Repository means just like our library. It is a repository. Library is a repository. It contains the books, right? Similarly, here you will see a list of virtual machines. Right? Suppose you have asked about two virtual CPUs, right? So we check the virtual machine list, right? One virtual machine, let's say with the two virtual CPU is there, another virtual machine with one virtual CPUs, another with four virtual CPUs, another with 8 virtual CPUs. So these all are under this particular repository. Then we'll see which particular virtual machine match your requirement. Obviously, the last three will match your requirement, but your requirement is perfectly matched with the second one. Then this request is given to the server, which we call as ESXi server, right? So this server actually what it is going to do, it has to deploy a particular virtual machines. So finally the request is reached to the virtual machine cluster and this virtual machine is provided to the that particular user. The user make a request and this background work is done by the provider and provider provides this infrastructure, this particular virtual machine to the user in order to execute some application, in order to run some application, in order to test a particular application, right? So this is the complete situation in a utility computing infrastructure. Now you can see utility solution. So there is two end. One is consumer end, another is called as provider end. Consumer and provider, they need to meet in a particular place. That is called as marketplace. In cloud case, we call that as a cloud marketplace. Consumer has certain requirement, provider has something to give. So they need to meet in a particular point. Like I mentioned about Amazon Web Service, you are creating one account in Amazon Web Service or requesting some service, right? So that is also a marketplace. Suppose somebody will say, I am going to use Google Cloud. You can switch on to the Google Cloud, right? You can create a account in Google Cloud and you can use the services. Somebody interested in some third party, another cloud service provider, that also you can do. So consumer and provider meets in a particular point to exchange the resource. We call that as a cloud marketplace. For example, if you look into consumer and service procurement, tell me if you need a particular service, whether you are in consumer end or in a provider end, you need some service. Let it be water or electricity or whatever may be. So you are a consumer or you are a provider. Can anybody tell? I need a service, right? I want to purchase a particular service. So whether I am a consumer or a provider,
Sir, consumer.
consumer, right? Now coming to service assurance. Okay, I need my service should be my service, the service which I'm requesting to my cloud service provider, it should be follow some terms and conditions. Some assurance should be there. So that is also requirement of a consumer. And availability of the resources, right, should be there. So that is my expectation. I'm expecting that the resource which is provided by my cloud service provider, it should be available. So that is also comes under the consumer. Contractor management, that is also a consumer. Consultants, that are also consumer. Sometimes user is not willing to create an account because user is not aware of the system. So in place of user, some consultants, some brokers are acting on behalf of a particular user. Like I am delegating someone, right? I cannot attend a particular meeting. So I am delegating my subordinate or my colleague to attend that particular meeting, right? So that is also treated like a consultant or a broker, right? Sometimes in order to use the cloud system, user may not feel comfortable to use the cloud infrastructure. So what the user has to do, user will delegate that thing to a broker. The broker has to do on behalf of the user, right? So there also the broker or these consultants will help in place of a consumer. Similarly, infrastructure procurement. I need more infrastructure. Right? Today I have 30 servers. I have seen there is a enormous requests are coming. I want to increase the 30 server to 50 server. So it is provider responsibility to increase the infrastructure. Equipment maintenance. Suppose 30 servers are provided to a particular customer. Total you have, let's say, 5,000 servers. So who is going to manage these 5,000 servers? Who is going to who is going to check the status of these particular servers? Your provider. Similarly, who is ensuring resource utilization? Whether the resource is utilized 10% or 30%, user need not bother about it, right? So as a provider, you have to see that your utilization should be increased to a greater extent, right? So that's why resource utilization comes in the provider end. Similarly, if some technology is changed, like Windows 10 is there, tomorrow Windows 11 is coming. Nowadays also we are getting update related to Windows 11. Who has to install this Windows 11 in the servers? The provider has to do. Consumer did not bother about it. Consumer is only bother some amount it has to pay with respect to that particular service. Similarly, other things you can see system admins, capacity planning, these all are part of the provider. Okay, and the point they are meeting, that is for the market. So in marketplace also some of the important policies there, like one of the important part in the marketplace is our service level agreement. What is service level agreement? Service level agreement is a contract between consumer and provider. Just like I mentioned you about warranty card and guarantee card. So here SLA explains about a particular service, how the services is going to be provided by the cloud service provider. What terms conditions are there? What about reliability? What about durability? What about availability? These all are mentioned in the service level agreement, including pricing also, right? Whether you pay $1 per CPU per hour or you pay $3 per CPU per hour, these all are need to be reflected in service level agreement. What security policies you will use, what security policies you are using to maintain your infrastructure, these also need to be mentioned in the service level agreement. And when you deploy a particular application, you don't know how many people will be interested in such application. Like you, all of us are using Google Play Store. Tomorrow maybe a new application will come. You may see this particular ad in a e-commerce site, or you can see this particular ad in a newspaper, or you can see this ad in a online shopping website or e-commerce website. There may be a huge demand of that particular application. So suddenly the number of users for that application increases. So that is called as your application sizing. This also need to be mentioned in the service level agreement. That's why standardization of the service level agreement, I told you in beginning class also, any standardization, suppose you are purchasing a particular product, then you are asking about hallmark, you are asking about ISI mark, you are looking into ISO standard, lot of things you are looking into that particular product. What these standards, norms looks or provides you, they provide some standardization. A proper process is followed for that particular product, right? So all these things need to be mentioned in the service level agreement. Now coming to utility computing payment models, like I already discussed two payment model. One is called as flat rate or based upon the usage, which we call as pay as you go or pay as you pay for usage. Okay, flat rate means you will get the service for 30 days or 40 days or 60 days or 365 days. The amount is same, right? The amount is same. Like our mobile phones also, right? Every day it is meter reading, right? You can see there is another pricing. It is written as meter reading. Meter reading means suppose you make a call and the call is ended at 000001. Let it be second, let it be minute, let it be hour. Then 1 unit is over. Another scenario, suppose 000059. How many units will be deducted? How many units will be deducted in this case?
Sir, 1 unit only, sir.
1 unit only, right? So this is called as meter reading. Right? Earlier telephone calls, landline phones, we have meter reading. But nowadays we are not using landline. Most of the government officials they are using, government organizations are using. But rest of the organization nowadays we are using mobile phones, right? In mobile phone we have a flat rate, right? Some 719 rupees we are paying. Okay, just I'm giving an example for 84 days. That's all. The call is unlimited, internet is unlimited, or internet is given as a 2 GB, which is sufficient for an individual user. Okay. There may be different tier. Like we have seen different architecture is having tiered architecture, tier 1, tier 2, tier 3. Just like you can say 1 GB plan is one tier, 1.5 GB plan is one tier, 2 GB is another tier, right? And 3 GB is another tier. So user has to choose one tier based upon its use, right? So that type of pricing schemes are called as tiered payment model. There is any subscription based model. You are subscribed. There are different methods are there. For example, one scheme you are getting more, let's say more internet, but you are getting less units of call. Another case you are getting more internet, let's say more SMS, but less calls. These all are subscriptions. So you have to decide which one is required for you, right? So these are the terms I'm telling in example. I'm giving example with respect to mobile network. But when you go for cloud, you have to see with respect to computation power, storage, and network. Like you can see, I'll tell you, there is an instance called T2 dot small instance in Amazon. I'll show you this thing in later classes. So this is a small instance. Similarly, there is a T2 dot large instance. So that is resources provided in this small instance is different from T2 dot large instance. Obviously, in large instance, they will give you uh, more power in comparison to T2 small instance. So you have to subscribe which one you need. Like many publishers are also providing whether you need electronic or you need print also. Electronic plus print. So in electronic case, you will get only electronically copy, right? One PDF copy, okay, in your email. If you subscribe to hard copy, they will send you a hard copy via post, okay. And there is also something called the standing charges. So different schemes are there, right? What I try to convince through different payment methods, models are there. You can choose your model as you like. Based upon your usage, you can decide. Based upon subscription, you can decide. Based upon, let's say, your organization need, you can select one payment method. So different pricing models for different customer based on factors such as scale. Okay, scale says that suppose today you are using a small instance, tomorrow you have decided to go for large instance. So based upon scale, you can decide which one is better. Based upon the commitment, you can choose a model. Based upon the payment frequency, also you can choose. Right? You want to pay, let's say, per month basis, or you want to pay per year basis, annual subscriptions, right? So based upon that, you have to choose an appropriate pricing model for your organization or for individual users. But the principle of utility computing remains same. You use flat rate, you use tiered, you use subscription, any model you want to use it. But the all the models are a part of our utility computing model. The pricing model is simply an expression by the provider of the cost of provision of the resources and a profit margin. So definitely somebody is providing the resources means there is a profit margin. So for owning that particular resources, they have to see that how much cost they incurred for that particular instance. Let's say for a T2 instance, small instance, they assume that the cost is, let's say, $1, okay, per day. I'm giving an example, rough example. So they can offer with, they will add some profit margin and they can provide, let's say, $1.2 per day. So all the instances, all the resources are provided like that by adding the profit margin. But what are the main risks? These risks are not associated with utility computing only, but this is also true for all the computing paradigms. Okay, like data backup, right? Data backup is one of the risks, right? If you are not taking backup in a regular interval, then if there is any data loss happen, then everything is gone, right? Because these are not a part of your system, right? Your systems, you are not keeping anything. Everything is there in the server. Let's say, for example, the Google server is crashed. Then what happened in if that particular server only contain your email? Imagine that none of the other servers contain replica of that your emails. Then gone, right? Your emails are gone, right? So data backup is always a risk in the utility computing world. Similarly, what about security? Security you can enforce if data is controlled by the user. But here the data is not controlled by the user. Who is controlling your data? The data is controlled by your cloud service provider. Obviously, there is an agreement between you and your cloud service provider. They are not going to leak the data casually, right? They will not simply give your data to someone, right? But as the data is not under you, so there is a question rises with respect to security. Okay, whether they are taken proper care or not. Similarly, another is called as partner competency. Your cloud service provider is your partner, right? But whether your cloud service provider maintain that particular partnership or not. Because the same thing is available, whatever you have given, the same thing is directly available to your cloud service provider. So we have some trust in our cloud service provider. So that's why we think that our data is not going to be leaked. It is not going to be given to any third party. So partner competency is also a risk. And defining service level agreement is also one of the risks, because service level agreement is prepared by the provider, not by the customer. Like whenever we are purchasing a particular product, the warranty card, guarantee card is given by the provider, not by the customer. And for customer, hardly it matters what is written in that card. We are not reading all the terms and conditions, right? So this SLA standardization, because we are not looking into what are the terms and conditions given in the SLA, which terms and condition is more sensitive, which terms and condition is less sensitive, right? That we don't know. That's why defining a service level agreement in the customer perspective, it is very challenging. And it is not a mutual consent between the provider and consumer. Moreover, getting the value from the chargeback. Everybody wants that if something we have spent, definitely we will get some benefit from for the amount we have spent. Some amount you have paid, right? So you will always expect that some amount whatever amount you have spent, for that you will get the service. But if there is a internet breakdown happen, okay, if your cloud service provider is not able to manage something, then again that is a risk to uh, in risk to both the customer as well as the provider. Right? Provider will not provide the service and customer will not get the services. So you will not get whatever money you have spent towards your resources. Okay, so proceed further. The last important computing paradigm, which is we are going to discuss in upcoming classes, that is related to cloud computing, right? So till now we have discussed about grid computing, cluster computing, even a parallel distributed computing, utility computing. Now let us see whatever you have seen in these computing paradigm. By considering the benefits of these computing paradigm, the cloud computing was developed, right? So many people define cloud computing in different ways, right? Many organizations are also provided different definitions with respect to cloud computing. But one of the popular definition given by United States NIST. NIST stands for National Institute of Standard and Technology. So they define cloud computing as this particular definition they have suggested. So let us see this definition and understand each and every uh, terms very clearly. So they mentioned cloud computing is a model for enabling ubiquitous. Ubiquitous means anywhere. Cloud computing enables you to get the services anywhere. There is no restriction on any particular location. We are not restricting that by the help of uh, a computer system or by the help of a workstation or server. You can access to the cloud. Rather than you can use from any location and any device also. As for the convenient, enabling convenient. As for the choice of the user, user can use the services from mobile phones also. Like in your mobile phone, you can check you have Google Drive. If you have stored some data in your Google Drive, you can use that Google Drive in your laptop. You can use your Google Drive in your institute computer system. You can use your Google Drive in your mobile phone. So it is up to the user, right? Which device the user want to use. It is up to the user to decide where the user want to use, right? Whether it is home, whether it is official location, whether you switch to some other country also, you can use the services provided as to services provided by your service provider. You can get it, for example, you can get your emails wherever you want to access it. And these services are provided on demand. Yeah, yeah, please. Hello. Is there any question? Am I audible?
Sir.
Yes, sir, you're audible.
Yeah, is there any question?
No, sir. No, sir.
Yeah, okay. Okay. Ubiquitous means anywhere. Convenient means as per your convenience, you can do anywhere, there is no issue. On-demand network access. Whenever you require it, provided you have internet connection, you can use the services provided by your cloud service provider, right? And these services is provided to you from a shared pool of configuring the computing resources. So there is a large pool, like I take an example of a non-technical example, that is called a swimming pool. In swimming pool, you can see large, plenty of water we have, right? In the similar fashion, here also you have a pool of configure computing resources. What are the computing resources you have? It may be networks, it may be servers, it may be storage, it may be applications, it may be any services, any computing services you require, that will be provided from a large pool. And we consider this particular pool as a infinite pool. Practically, there is nothing called infinite, but we treat this pool as an infinite pool because we know that whatever requirement a user will give, that requirement is very very small in comparison to this particular pool, right? Like if you consider in a particular city one home, right? A home area against the area of a particular city. So it is just like a small one, right? That's why we consider the city is an infinite one. In the similar fashion, here we consider the resources that are available in your cloud service provider, that is called as unlimited resources. As much as resource possible, you can ask to your provider. Okay, that can be rapidly provisioned. So provisioning these resources will be very immediate process, right? Now you have given your basic information, you have provided your payment information, you can simply use the cloud services. There is no delay in providing the services. It will be immediately provided and it will be released with minimum or minimal management effort. With some effort means some informations that you have to provide. Within that, it is going to be provided. Like just imagine you want to fill a particular form. That form is having 20 questions, right? But out of 20 questions, 10 questions are very basic questions. And let's say these 10 questions, you know what is the default answer. Like somebody will ask you, you write your country name. So instead of asking the user to choose a particular country name, you can by default write India is the default country. Other countries will be there. Those who are not belongs to our country, they will write other country name. But you can make such option available so that user can easily fill that particular form, right? So with a minimum management effort, these resources will be provided to the user. With the service provider interactions, the interactions between the cloud service provider and consumer makes release of the resources with minimum effort. Like here you can see, like if you consider a particular user, a user is requesting a cloud service provider through user has to first start a web browser, open a web browser. The different web browsers we are using, you may use Internet Explorer, you can use Mozilla, Firefox, okay, you can use Google Chrome, or mobile phone, suppose you are using Opera Mini, any web browser you require, any web browser you have, at least one one web browser is required to get the services from the cloud service provider. So once you have a web browser, you have to type a website like we are typing for Amazon.com, right? Or we are typing EC2 is a particular service provided by Amazon, EC2.amazon.com. Then you have to provide your username and password. You have to see which resource you require, whether it is a storage resource, Whether you need a storage service or you need a compute service, you need a database as a service. This service you have to choose. You have to select appropriate service. Then the service is going to provide you the resources. That's why with minimal management effort, the service will be provided to the customer. Okay, because if you ask a lot of information, user will not feel comfortable to use the services. That is the reason why the services are provided with minimum effort. So there are number of characteristics defined by this United States NIST. There are 5 different characteristics given specified by NIST US while defining cloud computing. They also defined 3 different services, 5 different characteristics you can say, or you can say essential characteristics, 3 different services, and 4 different deployment models. Deployment models are defined by NIST. So if you go for NIST, if you type in Google NIST US cloud computing, then you can get a PDF file. In that PDF file, they mentioned about 5 different characteristics, 3 models, some or 3, 4, 5 model. Okay, that 3, 4, 5 means 3 are the services, 4 is the deployment model, and 5 is the characteristics. Similarly, here 5 is the characteristics, 4 is the deployment model, 3 is the number of services. Right? So you can see these are the some of the services. Like I'll tell you about these services in the upcoming class. But you can see what are the different type of services we have. We can take database as a service. We can go for any application server also if you need. You can ask for the services. If you want to develop a particular application, you can focus on the development rather than how to deploy this application. Deployment part you need not worry, but you have to focus only on the development of the applications. And any device, whether it is a mobile phone or it is a personal computer, you can use the services that are provided by cloud computing, right? So although these are the different characteristics specified by NIST, but you can see there are number of characteristics apart from these 5 characteristics is suggested by various researcher, various companies. They have suggested different type of characteristics based upon their usage and based upon their view to the cloud computing, right? The perspective of different companies, different organizations is different. So NIST mentioned some characteristics, but people have further mentioned some more characteristics related to the cloud computing. So related to these different characteristics and services deployment model, we'll discuss in the upcoming class. So thank you. We'll stop here. But if you have any questions, you can ask.